When you have a DeFi project, a lot of time you manage some tokens on behalf of someone else. Instead of just letting all this money sitting uselessly on your smart contract, what if you could lend these tokens and earn some interest? Well, you can do this with Compound. Compound is a DeFi project that allows to borrow or lend tokens in a decentralized way on a smart contract. In this video, I will introduce you Compound and explain how you can interact with it from Solidity and JavaScript. Hey, I'm Julian, and on my channel EatTheBlocks, I teach blockchain development and how to get your first blockchain job. Before we dive straight into Compound, let's understand the different kind of loan that exist. You can have two kinds of loan, secure loan or non-secure loan. For a non-secure loan, you can borrow money without providing any asset as collateral. However, in general, people want to have some proof that you'll be able to repay the loan. For example, you can show how much money you're making. You can also show your credit history to prove that in the past, when you borrowed money, you paid it back. Some example of unsecured loan are government bonds or company bonds. The other kind of loan, called a secure loan, requires the borrower to provide an asset in exchange of the money that is lent. We call this asset the collateral. At the end of the loan, if the borrower does not reimburse the money, the collateral will be given to the lender to cover for the losses. An example of that would be when you take a mortgage to buy a house. If you fail to pay back the mortgage, the bank is going to take back possession of your house and sell it to reimburse itself. On the blockchain, Compound chose to do secure loans, where you have to provide a token collateral in order to borrow. In order to borrow, you also have to pay some interest. Like for Uniswap, you deal with a pool of liquidity. So borrowers and lenders never have to deal with each other directly. Loans don't have any predetermined duration, and borrowers can choose to pay the loan back whenever they want, as long as the value of their collateral remains above a certain threshold. They can keep the borrowed asset. Otherwise, the collateral will be seized, it will be sold, and the proceeds will be given to the lenders to cover for their losses. So now let's dive deeper and see what are the smart contracts of Compounds. So first we have the cTokens smart contract. So these are self-contained borrowing and lending contracts that really contain the core logic for borrowing and lending tokens. There is one cToken smart contract per token. Contrary to Uniswap, you cannot decide on your own to create new markets, so you have to deal with all the cTokens that already exist, and if you want to add new market, then it has to be created by using the governance mechanism of Compound. You can see all the markets available at this address. So you will interact directly with one of these smart contracts when you want to lend token or borrow token. Then we have the Comptroller smart contract. So when a user wants to borrow some token, then the controller is going to check that this user has enough collateral across all cTokens. So there are a few actions that require you to interact directly with the controller smart contract, but in most cases you won't have to interact with it directly. Instead, that will be the cToken that will ask the controller if they can do some actions. So there are still some other smart contracts in the Compound system, but these are really the main one. So now let's see the full process for borrowing some token from Compound. So the first step is to provide some collateral to the Compound system. For example, if we want to use DAI as a collateral, then first we will send some DAI to the cToken for DAI. So we call this cToken cDAI. So we send the DAI, and in exchange, the cDAI smart contract is going to give us another token, which is called cDAI. So cDAI represents the DAI token that we send to the Compound system. And at any time, we can redeem this cDAI token against the real DAI token that we first sent. By the way, all these cTokens are ERC20 compliant. It's easy to manipulate, and we even have some wallet that can show you your cTokens balance, such as MetaMask. The second step is to call the enter market function in the controller smart contract. And by calling this function, you specify to the Compound system that you are willing to use a certain set of tokens as collateral for borrowing other tokens. So you might wonder, well, this is a bit strange that we have to do this. Doesn't Compound already assume that all the tokens we send to it will be used as collateral? Well, no, because by default, when you first send your token to Compound and you get some cToken in exchange, at this point you are not a borrower, but you are a lender. That means that Compound is going to pay you for all the collateral that you provided. So in the example before, I just mentioned DAI and CDAI, but if you wanted, you could provide many other kind of collateral for all the markets that Compound support. However, once you start a loan with Compound, there is something called the liquidation process. So if the combined value of all your collateral on Compound fall below a certain threshold that we call the collateral factor, this is specific for each token. If that happens, your position is judged too risky and anyone can liquidate your position, which will basically make you lose possession of your collateral. So you need to specify to Compound, out of all the assets you provided, which one you want to be at risk so that you can borrow other tokens. The next step is when you're going to actually borrow the token. So for example, if you want to borrow the BAT token, then you're going to call the borrow function on the CBAT smart contract, and it's going to give you some BAT that you can use in whatever way you want. There is no duration for the loan. You can pay back this BAT token whenever you want. When you do decide to repay your loan, you will send your BAT token to the CBAT smart contract. So you will need to not only reimburse the token that you borrowed, but you will also need to add the interest. So the longer the loan, the higher the interest. The interest rate is fixed by the Compound system on the blockchain, and it depends on the supply and demand for the specific market where you borrow your token. And the last step is to get back the original DAI tokens that you sent to Compound. So for that, you're going to redeem your CDAI token. So the CDAI token is going to be sent back to the CDAI smart contract, and in exchange, CDAI is going to give back your DAI token. And you're going to get back slightly more DAI that you initially sent to Compound because you earned some interest during all this time. But if you want to keep earning interest, then you don't need to redeem your CDAI, and you can just leave it in Compound and you will keep earning more and more interest. So next we're going to do some coding, and I'm going to show you from a Solidity smart contract how you can borrow tokens from Compound. So here I am in Remix and I have created a smart contract. I'm using Solidity 0.5.12 because the smart contract of Compound require at least this version, but it probably also works for Solidity 0.6. So first we need to import a couple of interfaces because we're going to interact with a couple of smart contracts. So first we're going to interact with ERC20 token. So for that, we're going to import the ERC20 interface of OpenZeppelin. If you don't know what is OpenZeppelin, check out this tutorial series. So here, this is the GitHub repo of OpenZeppelin, and I am inside the ERC20 directory. And so what we need is irc20.sol. So that's the interface for ERC20 token. You're going to copy the URL, then we're going to go back to Solidity, and here we're going to import the URL that we've just copied. Okay, so we've imported the ERC20 interface. So next we're going to import the interfaces of Compound that we need. So we need to interact with two kind of smart contract for Compound. One is the Comptroller and the other one is cTokens. So next we're going to the GitHub of Compound, and we're going to go inside the Compound protocol repo, and we're going to scroll down and go to the contracts folder. Let's scroll down, and here you'll see a file called Comptroller interface. So that's what we want. So you're going to copy everything in this file. So we won't need to use all the functions, but it's just better to copy the whole interface. Then let's go back to Remix, and we're going to create a new file. We're going to call Comptroller interface.sol. Let's paste everything. All right. So back to the main file. So we're gonna import this controller interface. Okay, next let's go back to the GitHub repo of Compound. Let's scroll down, and here you will see another file called cToken interfaces. So let's click on that. Let's scroll down again. Okay, so here you're gonna see a first set of function, transfer from, etc. So you're gonna copy this from transfer up to C's. Okay, let's go back to Remix. We're gonna create a new file called cToken interface.so. Okay, let's put the pragma statement here, Solidity 0.5.12, and here we're not going to use the interface keyword, but we're going to use the contract keyword, because otherwise Solidity is not happy. I just spare you the detail. Contract cToken interface. Okay, and we still need to copy some function from the interface. So let's go back to the GitHub of Compound, and let's scroll down a bit, and here you will see some other function from mint to liquidate borrow. So we're gonna copy this, and for the other thing of the interface you can just ignore it for now. So back to Remix. Okay, let's paste this function. Alright, so now we have all the function we want. So back to my DeFi project, we're also going to import the cToken interface. So in this smart contract, we're going to provide as collateral some DAI to Compound, and we're going to borrow some BAT token. So we need to create a few variables to have pointer to all the different other smart contracts that we need to interact with. So we need first to interact with the DAI token. So let's declare a variable of type interface ERC20. That's going to be for DAI. Then another interface of type cToken interface. That's going to be for C DAI. Oops, by the way, here it needs to be .sol and .sol. Okay. Then we need also pointer to the BAT token and the CBAT also. So let's copy paste this. So we need BAT and here CBAT. And finally, we need a pointer to the controller. So controller interface, I'm going to call this controller. Okay, then we need to have the address of all this smart contract. So a good place to have this is inside the constructor. So we're going to pass all this address. So first the address of DAI, then the address of C DAI, then BAT, C BAT, and finally address of the controller. And of course these addresses will depend on which network you are deploying to. For mainnet it will be some address, Kovan is going to be another address, etc. So we make our constructor public, and inside we need to create these pointers. So DAI is ERC20 DAI, then C DAI, cToken interface of C DAI. Okay, let's copy this because for BAT it's almost the same. BAT, CBAT, and finally for controller interface. Okay, Okay, so that means that when you deploy your smart contract, you need to already know all of these addresses and pass it to your constructor. And after, in any other function, then we'll be able to use these variables here. So that will be very, very convenient. So the first step is to provide some collateral to the Compound protocol. So we're gonna create a function for that. We're gonna call it invest, and here we're going to use the pointer to the cToken of cDAI, so that's cDAI, and it has a function called mint where you tell it how many token you want to send it, and in exchange is going to send you some cDAI. For example, let's say we are investing 10,000 DAI. So if you do just this, do you think it's going to work? No, it's not going to work, because cDAI is going to internally is going to call the DAI token, is going to call the transfer from function, which is the delegated function for ERC20. But DAI will say, hey buddy, you're trying to transfer from your address, but you are not allowed to do this. So we need to allow cDAI to transfer token on our behalf, otherwise it doesn't work. So for that, we do DAI approve, and after we pass the address of cDAI, so we cast the pointer of cDAI into an address like this. After we pass the amount that we want to approve it for, so 10,000 for example. So of course you can modify this function, and instead of a fixed 10,000 number here, you can put it as an argument of invest. That's up to you. So with this, we have invested some DAI in the Compound system, and we have some cDAI. So our smart contract here, my DeFi product, possesses some cDAI. So we are earning interest actually. So next, we need to create another function to redeem our cDAI when we want to do the other operation and get our DAI token back. So for that, let's create another function that I'm going to call cash out. And so on the cDAI smart contract, there is a function called redeem, and we need to pass it the number of cDAI that we want to redeem. But the problem is that we don't really know, because the exchange rate between this cDAI and DAI token is increasing all the time with the interest that are accumulating. So we cannot assume that here we have 10,000 cDAI. So we're going to use the balance of function of cDAI to know what is our balance. So cDAI balance of, and here the balance of us, and after here we're going to pass it our balance of cDAI, and it's going to give us back all our DAI token. So we'll get back not only the initial DAI invested, but some interest. So next, let's see how we can borrow tokens from Kovan. So let's create another function that we're going to create borrow. So at the beginning, we need to do the same thing as we did before. We need to provide some collateral. Here, let's just copy paste this. Then with the Comptroller smart contract, this time we need to call a function called enter markets that signal to the Compound protocol that we want to use some token we invested in Compound as collateral for our loan. So this function accepts an array of cToken addresses. So if that was JavaScript, we could just do something like this. But this is not JavaScript, this is Solidity, so everything is slightly more complicated. So we're going to create this array of addresses ourselves manually. So here we're going to call this market new address, array of address, and the size of this array is 1. And at the first index, we're going to assign CDI. Sorry, here I meant markets. Okay, and here we're gonna pass markets. Okay. And the last step is to actually borrow the token. So for that, we're going to use a pointer to cbat. And there's a function called borrow where you specify how many tokens you want to borrow. Very simple. So of course, you need to make sure that the number of tokens that you invested as a collateral here, the value of this is superior to the value of tokens that you want to borrow. And you also need to consider the collateral factor. So basically the collateral factor tells you what is the extra value of collateral that you need to have in order to borrow some token. This is specific for each market. So here we're going to be very conservative and say, okay, well, we just want to borrow 100 BAT. That should be largely inferior to what we have here as collateral. And we still need to create a function to repay the loan when we want to reimburse it. So for that, let's create a function called payback. And so on the cbat contract, there is a function called repay borrow, and we need to pass it the number of underlying token that we want to reimburse. So here we want to reimburse 100 BAT token. And here, this is the same problem as what we had here, what I explained you in the invest function. We need also to approve our BAT token. Otherwise, the delegated transfer of ERC20 will not work. So here in the BAT token, we're going to approve the address of the cbat. And actually, we're not going to approve it just for 100 token, but we need to make some room for the interest. So here, let's say that the interest is 10%, which is pretty high, and we need to have kept the loan for 1 year to have to pay that. So here, instead of 100, then we're going to put 110, or actually you can put a higher number just to be really safe. So this is going to send back the BAT token to cbat. So after that, you have finished your loan. And optionally, if you want to get back your collateral, and so for that, we can copy what we had here in the cash out function. But here, this is just optional. So after you've created this smart contract, you need to deploy it to the Ethereum blockchain. So you have three options. First option is with local development. So you're going to deploy a local development blockchain like Ganache. Second option is you deploy it to a public testnet like Kovan. And the last option is you can deploy it to mainnet. Yes, I said mainnet, and this is still in a development environment, but by using a special trick of Ganache CLI that allow you to fork mainnet and have a local copy. First, I'm going to show you how you can do local development. So if you go back to the GitHub repo of Compound, if you go to the root of the repo and you scroll down, then you can see that it gives you some explanation for a local install. So first you need to clone the repo locally. All right, so I'm gonna go to my terminal and do this. Next, you need to step inside the folder of Compound Protocol and run npm install. Okay, so let's do this, npm install. And after that, you can deploy the smart contract of Compound with npm run deploy. It's going to deploy on a local Ganache instance. And after that, you should see the address of deployment inside the networks directory. So for example, you already have some addresses for all the network like kovan.json. Here you can see like die, cdi, etc. So after, what you need to do is to use these addresses and use them in your migration script when you deploy the smart contract of your DeFi project, and you pass all these addresses to your constructor. So the next deployment option is on a public testnet like Kovan. First, you're going to find the faucet for the public testnet that you use. So for example, if you use Kovan, use the Kovan faucet. It's going to give you some Kovan ether. Then you're going to get some DAI by going to the Oasis app of MakerDAO that allow you to borrow some DAI. So you're going to send some Kovan ETH and it's going to send you some Kovan DAI. And once your address has some Kovan DAI, you can use this DAI to provide collateral for the smart contract of Compound on Kovan and run your test like this. And the last option is to deploy your smart contract on a fork of mainnet. And you can do this by using a secret feature of Ganache CLI, which allow you to fork any blockchain. So you're going to operate on a local copy of mainnet that is only on your computer. So don't be afraid. You don't need to download all the data of mainnet, which is probably 1 terabyte at the time of recording this video. That would be absolutely impossible to do that. So instead, Ganache is very smart and it only downloads the data it needs in order to run the different transactions that you send it to. So this is absolutely doable on a normal development machine. So first, you need to install Ganache CLI on your computer with npm install Ganache CLI. And after, you're going to run it that way. So you're going to give it an option that is fork. And here you're going to give it the URL to a node that run mainnet. So we don't want to run mainnet on our computer. So what we're going to do is use the Infura service. So Infura is a public API that can run some Ethereum node connected to mainnet or any public testnet. So you need to create an account on Infura. After, you need to create a new project and you'll have different endpoints for the different networks, so mainnet and all the public testnet. So you change the drop down for mainnet, then you copy the URL. And after, you're going to paste your URL here. And after, you're going to paste your URL here. So just before, you need to give it https:// okay. And it's going to be something like this. And then you will also need to have some DAI to one of your address so that you can create some CDAI and provide some collateral to the Compound protocol. Actually, with Ganache, you can unlock any address. So without the private key of any address, you can still send transaction to your fork of mainnet from one of these unlock address. So that's very, very convenient. So you need to use the unlock the U flag, and after you pass the address that you want to unlock. So we want to unlock the admin address of the DAI token so that we can mint any amount of DAI. So we're going to go to etherscan.io, the blockchain explorer for Ethereum, and we're going to search for the DAI token. So here, DAI stablecoin. So let's click on the contract. And here we can see who is the creator. So the creator is the admin of this contract and is the only one who is able to mint any token. So let's click on this. Okay, so we copy the address here and after we paste it here. And after that, you press enter and it's going to start your local fork of mainnet. And so now in your deployment script, then you're going to mint some DAI token. So if you want to see how to use this mint function, then with Etherscan, we're going to go back to the DAI token. Here we can read the source code by clicking on contract. And if you scroll down at some point, you will see the mint function. So here you pass it the address, the recipient address, and then how many DAI needs to be minted. And after you have your fake mainnet DAI, then you can send them to Compound and run all your tests. If you want to know more about how Ganache CLI work and especially the secret forking feature, actually I've done a video just on that. Lending and borrowing token on the blockchain is very important, and in the next video of this series on DeFi programming, I'll show you Gnosis, which is a protocol for creating conditional token that allow you to basically bet on any real world event. This is super exciting. I'll see you there.